Have you ever wondered what it takes to build a machine that can literally move mountains? We're not talking about your average construction site digger. We're diving deep into the world of colossal engineering, uncovering the secrets behind the planet's largest excavators and cranes. These aren't just machines. They're modern-day titans, behemoths of steel that dwarf everything around them. So, buckle up, because today, we're going inside the unbelievable manufacturing process of the giants that shape our world. From raw steel to earth-moving monster, this is how it's made. Before a single piece of metal is cut, hundreds of engineers and designers spend thousands of hours in the digital realm. Using advanced computer-aided design, or CAD software, they meticulously plan every single component. We're talking about a digital blueprint that details everything, from the massive bucket that scoops up hundreds of tons of earth at once, to the intricate hydraulic systems that give these giants their incredible strength. They run countless simulations, testing for stress points, calculating load capacities, and optimizing fuel efficiency. Every bolt, every weld, every gear is perfected on screen long before it becomes a physical reality. This digital phase is crucial. A tiny miscalculation here could lead to a catastrophic failure in the real world, so precision is absolutely everything. It's a symphony of physics, material science, and pure innovation. Once the digital blueprint is finalized, the journey from pixels to powerhouse begins. The first stop, the steel mill. The sheer amount of high-strength steel required is staggering. We're talking about specialized alloys, formulated to withstand immense pressure, extreme temperatures, and constant abrasion. These aren't just ordinary steel plates. They are gargantuan slabs, some as thick as a foot, weighing many tons each. They arrive at the factory looking like blank canvases, ready to be transformed. The scale of the raw materials alone gives you a hint of the epic final product. This is where the brawn of the operation truly starts to take shape. Now for the real magic. Fabrication. How do you cut and shape steel plates that are thicker than a car tire? You use some of the most powerful tools on Earth. Gigantic plasma and laser cutters, guided by computer programs, slice through the thick steel with pinpoint accuracy, following the digital blueprints from the design phase. It's like a hot knife through butter, but on an industrial, almost unbelievable scale. Then comes the bending and shaping. Massive press brakes, exerting thousands of tons of force, bend the flat steel plates into the complex, curved shapes needed for the boom, the chassis, and the operator's cab. Every piece is custom-made, a unique part of an enormous puzzle. With the individual components shaped, it's time for them to be joined together. This isn't your garage welding project. We're talking about robotic welding arms and highly skilled human welders working in tandem. The seams on these machines are critical. They have to be flawless to bear the colossal stresses the excavator will endure. Robotic welders handle the long, repetitive seams, ensuring perfect consistency and strength. Meanwhile, expert welders tackle the more intricate and hard-to-reach joints, their skill ensuring the structural integrity of the entire machine. After welding, each seam is meticulously inspected using methods like ultrasonic testing, searching for any invisible flaws that could compromise safety. It's a slow, painstaking process, because when you're building a giant, there's zero room for error. Now, let's assemble this beast. This process is like building the world's largest, most complex model kit, but with parts that weigh as much as a house. The assembly takes place in enormous purpose-built hangars. First, the massive undercarriage, which houses the tracks, is put together. These tracks alone can weigh over 50 tons each. Then, the giant slewing ring, a massive bearing that allows the upper structure to rotate 360 degrees, is carefully mounted. This is a critical moment. Using immense overhead cranes, the main body, or superstructure, which contains the engine and hydraulic systems, is lifted and carefully lowered onto the undercarriage. The precision required is measured in millimeters. It's a breathtaking dance of heavy machinery, a true testament to modern engineering. What gives these giants their muscle? The hydraulic system. This is the machine's heart and circulatory system, a complex network of pumps, valves, and massive cylinders. The engine, often a diesel powerhouse generating thousands of horsepower, drives powerful hydraulic pumps. These pumps pressurize special hydraulic fluid, sending it through reinforced hoses to the hydraulic cylinders. When this high-pressure fluid enters a cylinder, it pushes a piston, generating incredible force. This is what moves the massive boom arm and bucket, allowing the excavator to lift hundreds of tons with graceful, controlled movements. Installing this system is a delicate task, ensuring every connection is secure and leak-proof. The power is immense, but it's all about control. Of course, a titan needs a brain. The operator's cab is the command center of this entire operation. It's not just a seat and some levers anymore. Modern cabs are ergonomic, climate-controlled environments packed with technology. We're talking multiple joystick controls, touchscreen displays showing real-time data from sensors all over the machine, GPS for precise digging, and advanced safety systems. The cab is carefully designed to provide maximum visibility and comfort for the operator, who might spend 12-hour shifts inside. It's insulated from the noise and vibration of the massive engine, creating a surprisingly quiet workspace. From this high-tech cockpit, a single person can command thousands of horsepower and move mountains of material with fingertip precision. Before this giant can be unleashed on the world, it undergoes a brutal series of tests. Quality control is paramount. Every system is checked and double-checked. The engine is fired up for the first time, the hydraulic pressures are monitored, and every function is tested without any load. Then, the real tests begin. The machine is put through its paces in a dedicated proving ground. It digs, it lifts, it rotates, all while sensors collect data on performance and stress. Inspectors check every weld again, listen for any unusual noises, and ensure that every single component is performing exactly as designed. Only after passing this exhaustive gauntlet of checks and receiving a final coat of paint and company decals is the excavator finally deemed ready for delivery. From a digital concept to a mountain-moving reality, the creation of the world's largest excavators is a monumental achievement of human ingenuity, precision, and power. It's a process that combines brute force with delicate precision, a perfect blend of mind and machine. These steel giants are more than just tools. They are symbols of our ability to dream big and build even bigger. They are the unsung heroes that build our minds, our dams, and our cities. The next time you see a massive construction project, take a moment to appreciate the incredible journey of the machines that make it all possible. Thank you so much for joining us on this incredible manufacturing journey. If you were as amazed as we were, don't forget to hit that like button, subscribe to the channel, and ring the bell so you don't miss our next deep dive into the world of epic engineering. Let us know in the comments what amazing machine you'd like us to feature next. Until then, keep wondering and keep building.